Hello YouTube, and in this video we are starting chapter 10 of the Linux from Scratch book, and this is quite a short chapter. I had a quick look over this, and what we're going to do, we're just going to read the introduction, and it's a very short one, and it says it is time to make the LFS system bootable. The chapter discusses creating the etc fstab file, building a kernel for the new LFS system, and installing the Grub bootloader so the LFS system can be selected for booting at startup. Now, I might not do Grub in this video, and the reason for that is I may get the Debian Grub to boot this. I need to look into that. However, we can do the other two parts, and I think I'll do fstab, the Grub, in a separate video. So the first thing we need to do is do the fstab. So this is like pretty simple. We do lsblk. I think we have that. Yeah. So we have, these are the Debian partitions, these ones. I'm not sure what SR0 is. And we got the BDB, BDB1, which is the root partition for the LFS. And we got BDB2, which is swap partition. I don't actually like swap partitions. I think they should have a swap file. However, we have a swap partition. If I ever do this again, firstly it'll be automated, and secondly we'll have the swap partition. VDC is where I'll put backup for the LFS system. So if I was to go, I didn't show you this in the other videos, but if I do mount LFS backup, there is the temp tooling from chapter 6, and this was the pre-strip backup. So if we have to do any of these chapters again, I've actually got the bits and pieces here just in case anything messes up. However, I can always boot into Debian and just fix stuff. And that's one thing I don't want to break, is booting into Debian, because then things will get a lot harder, because I'll have to, I don't know what I would have to do, because it's all in a virtual machine. It's not like a physical disk, and I would have to mount it, make another virtual machine and mount it, and do some other bits and pieces. However, back to the fstab. So let's just read the bits and pieces that we need to read. So the etc fstab file is used by some programs to determine where the file systems are to be bounded by default. Now, if let's just have a look at the Debian fstab. We just do cd. Let's go back home, and we do cat etc fstab, and that's not great. Let's just dim it so we have some syntax highlighting, and we'll make this bigger so it's a bit easier to see. And that's the UID of the root partition. Notice it's done by ID, and in previous chapters there was a discussion about whether you should do mount by ID of the device or by the actual physical location. We're going to do the physical location because that's what LFS is doing. The physical location is like where it is in the machine, but this is a virtual machine, so there isn't any actual physical location. It's just a virtual location, which is it is basically emulating a physical location. So if we just come out here quickly, and we go to info, we got the lib images, blah blah blah. That is disk 2, and to the virtual machine, this is just a 30 gigabyte disk that's logged in. So we go back there. Sorry if it's a little bit small. I've got a very high resolution monitor, but I can't make this any bigger. So there we go. So what we're going to do is VDB1 and VDB2, and what we have to do is substitute XXX and YYY, and it says that in the next piece. So it says, so this is the fstab file, and it's got all the sysffs and procfs. Now Debian doesn't have that, and I'm not entirely sure why. I'll have to research that. But these videos have been going on long enough. So now I want to move on to something else eventually. Even if it is doing BLFS. So what we're going to do is we're going to just copy this. I should read this piece first, sorry. So replace XXX and YYY and FFF with the values appropriate for the system. For example, SDA2, SDA5, and EXT4. So I've forgotten. How do I find out the file system? I think it was EXT4. Come on. Can't type. Oh, DFT. So do I have that? So EXT4. Right. So that's EXT4. That's fine. So if I could have just done command DF by the looks of it, and what does T do? I know, print the file system type. Okay, that's exactly what we wanted. I could have just read, didn't know DF could do that. Okay, so let's clear that. Let's close that, we don't need that anymore. And so that's going to be VDB1, VDB2. So XXX is going to be VDB, BLK again, because I've got memory like a sieve. That's going to be VDB1. So XXX is, yeah, XXX is VDB1, FFF is EXT4, and that's VDB2. So what we're going to do, I'm just going to use Vim again, because it's just easier to edit in Vim rather than doing it on the command line. So we're just going to do that. And then we're going to do Vim etc fstab and that is ooh, I don't like it when it does. No. I'm not sure if this is fussy about spaces. What is it doing? Why is it doing that? What? Seriously? And that is going to be why wouldn't it line anything up? I'm sure there's a reason why. Let's just hope that doesn't. All right, so that looks like it's more or less correct. So we're just going to right click that. I think it matters the tab in. So find out, I guess, when it doesn't boot. So that's that done. It says some stuff about some file system MS-DOS and Windows Origin, IEB, FAT, NFS, Samba, FS, CFSS, ISO 9660, UDF. These special options, basically it's saying that you have to set some special extra options. I don't care about that. I don't think any of this is relevant, so we're just going to skip the rest of it. I'm not going to read out all of these bits. It's just, I don't think it's relevant. I'm not mounting any of these, so I don't care. So we're going to skip that. And next, we're going to be doing the Linux kernel. We're going to install the Linux kernel. So it says the Linux kernel package. The Linux package contains a Linux kernel. And if I can read properly, with one, hopefully by the end of this, I can actually read a sentence correctly. And this is installation of the Linux kernel. Building the kernel sources involves a few steps: configuration, compilation, and installation. Now, I have done this a very long time ago, and usually whenever I build a kernel, I'm usually building somebody else's kernel with somebody else's configuration. I never configure it myself. I kind of don't like doing this because it's got all sorts of weird names for devices. I usually don't know what they are. So I'm going to use pretty much whatever they suggest as default. Read the README file in the kernel source tree for alternative methods to the way this book configures the kernel. I'm not going to do that. I'm going to use exactly what we should be doing. So the first thing we need to do, though, we need to go to sources. And in sources, there is the Linux kernel somewhere, I'm guessing. Linux 6.3, there we go. And we need to extract this. And it's the same, it's tartxf Linux. And this, should have put a V option in there. This usually takes a little while. All right, there we go. Building it says important. Building the Linux kernel for the first time is one of the most challenging tasks at LFS. Getting it right depends on the specific hardware for the target system and your specific needs. There are almost 1,200 configuration items that are available for the kernel, although about a third of them are needed for most computers. The LFS editors recommend that users not familiar with the process follow the procedures fairly closely. Yeah, I am familiar with the procedure. I have built 2.4 and 2.6 kernels. I don't think anything's changed massively in how to build stuff. However, I'm going to do... the objective is to get the initial system to the point where you can log in at the command line when you reboot later in section 11.3, rebooting the system. At this point, optimization and customization is not the goal. Yeah, so that's kind of what I was saying in the last chapter. I just want to get something to boot. If I can get something to boot, I can fiddle around with it later. For general information, the kernel configuration, you see blah, 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 kernel configuration.txt. Then there's the link here. Might read that later. Additional information about the configuration and building the kernel can be found at kernel nutshells. Okay. Oh yeah, this is I recognize this name from somewhere. I think he's a Linux kernel maintainer or something. I can't remember. These references are a bit dated, but still give a reasonable overview of the process. Okay. All else fails, ask for help on the LFS support mailing list. Yeah, it's not the 90s anymore, man. Note that subscribing is required in order for the list to avoid spam. Okay. Right, so we need a CD into the Linux kernel, which we haven't done. And it's make M proper. That's done. So what that does is basically make sure that the tree is clean. Yeah, this ensures that the kernel tree is absolutely clean. The kernel team recommends that the command be issued prior to each kernel compilation. Do not rely on the source tree being clean after untarring. There are several ways to make ways to configure the kernel options. Usually this is done through a menu-driven interface. Right, so yeah, so it says there are several ways to configure the kernel options. Usually this is done through a menu-driven interface. For example, make menu config. The meaning of optional, what does it say here? The meaning of optional make environment variables. LC host lang val LC all equals. Establish the locale setting of one use of the host. This may be needed for a proper menu config encoded interface line drawing on a UTF-8 Linux text console. We use British English. It's the same. I think it will probably be okay. If used, be sure to replace host lang variable by the value of the lang variable from the host. You can alternatively use instead the host value of LC all or LC underscore C type. Why is this not clicking off? Okay. Right, now it says a note here. It says a good starting place for setting up the kernel configuration is make deb config. This will set the base configuration to a good state that takes the current system architecture into account. Be sure to disable, set the following features on the system, or the following features, or the system might not work correctly or boot at all. It's got a list of features that I have to put up. All right, and there's like the reasons why. There's a lot of. Right, so what file did they say it was on here? Right, let's just go. I bet the README is going to be massive. Right, so this bit of the guide. Okay. Jesus Christ. I don't want to get into all of this. This is the sort of stuff I don't like getting into. All right. So what we're going to do, we are going to use this make def config, sorry, and then we'll do the other one and see how it goes. So we just quit this and we'll do make def config. Right, and then okay, we need to have a proper. It's going to be. How big do I need to make this? Right, so say here. So right, so we need to find pressure stall information tracking and control group support. Okay. See if that's in there. Can't even see this option. Right. Can't even see this option in here. So we got like basically a lot of options in here, and what I'm trying to do is try to find where it says precious stored information tracking. I'm not even sure what that means. Preemptive behavior, call scheduling, CPU task. Ah, here we go. Right, so exit. So that's that done. Control. Enable control group support. This one. Memory controller. And then we go exit. All right, and then we go exit. And we come to what was it? Purchase a type of features. And build a relocatable kernel. So if we can find this. This is set. It's a lot big set of options, as he said in the book. Oh God, how many of them are there? Yeah, so build a relocatable is already hit. I think that will be like unless you're doing a very specific build for a very specific machine, then you want that off. So they're both on. That's good. And then it says general architecture dependent options. That's that one. And stack protector buffer overflow detection. Stack protector that is enabled. Strong stack protector. Okay, that is also enabled. So good. And it says device drivers. And it says maintain dev temp fs file support to mount at dev. So if we click back in here, I need to make sure I'm in the right thing. Maintain. Can I just put M? No. EI to support. Yeah, maybe for my kernels. Old. Oh, is it A? No. Highlighted letters are hotkeys. Right, okay. But that doesn't work. Or doesn't seem to. It says up there highlight letters are hotkeys. Well, mouse is. There we go. But it doesn't. Dallas one wire support. I think Dallas clock port controller is like some Asians. I think that's off of Pentium 1 machines. That's it. Maintain dev fs. Let's go back up the top because I started talking. Am I in the right place? I need to go to generic driver options first. Okay. Yeah, I wasn't looking at the play. Yep. Yep. So, and then we go firmware drivers. So that's under here. Right. I understand what I'm looking at now. I was a little bit confused at the start, like how this works. I haven't done it in literally 2 decades. Mark VGA, blah, blah. What's it? Mark. Look. Let's see what it actually says. Right. So. That firmware drivers, Mark. The direct rendering manager. Now I can't see this. It's not a menu item. Oh. I don't care about EFI. I can't see that. Oh, it's under graphic support. I just didn't see that for whatever reason. I suppose that's. Oh, where were we? Graphic support. There we go. So we go back, and then it's. I'm guessing it's. Ba, 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 ba. There we go. Graphic support. Direct rendering manager X386, which is the old version of X server, higher DRI support, and then it says K message panic stream handler. I can't see that. All right, okay. So the K message in there. Right. And it's panic screen formatter. Okay. So enable legacy FB dev support for your mode. Ooh. So it's in here. Yep. Okay. And then it says simple frame buffer driver. So that will be under direct. So I am in the right one still. What was it? Simple frame buffer driver. Yep. Now when it's M, that means it's a module. I just remembered this. Yeah, so you can basically have like a frame buffer driver. So you could build certain things as modules as opposed to into the kernel. So the kernel would load that module at times. So you have a small overall kernel, and then it loads in the bits and pieces that it needs. I think that's how it works anyway. I could be completely wrong. Frame buffer console support. So did I do frame buffer console support? So I did simple frame buffer console. And then this, I can't see it. Now, these options are different. Let's just check. It's not in this. No, it's not. Okay. Intel XE graphics. Oh, they're the new Intel drivers. Very cool. Have a quick Google. This is a newer kernel though, so it's not quite the same. So it is in there though. I can't see it. And it's in this menu by the looks of it. In this menu? Yeah. Let's go back here. Debug. Right, we've got this panic stuff, I think. Sure, check whether that was enabled. Can't see it now. Oh, it's in supported DRM clients, isn't it? Yeah, that's fine. That was configured. But I can't see this. So, brain buffer console support. No, these are all too old. They're not. Boot logo. Do I want a boot logo? Probably not. I don't really care. See, brain buffer console support. So one more look in here. See, I don't know. Serious driver. Yeah, this is like. I might want that though. We've got Vertio. So if I go back up here, let's just check why I'm using Vertio. On. And I think it's got video card or something like that. Yeah, Vertio. So I think I'm okay on that. Let's make this big again. Yeah, I can't see it. Well, you know what we're going to do? We're just going to define frame buffer console support. Oh, you can do thing for search. Okay. What was it? This might be a bit easier. I remember doing this before. It's in device drivers, graphics support, console display drivers. Okay. So what was it? Device drivers, graphics support, console display driver support. So we need to go back to right. So that's there. So this is a little bit different. So I think the book's a little bit wrong here. But I now know how to use the search function. Right, so we've checked whether they're enabled, which they are now, which is good. And we're just going to go back to the top level, I think. Yep. And then we're going to do processor type of features. If we go to processor type. And it says support X2 APIC. I'm not sure what that does. And then it says device drivers. So we'll go back to device drivers, wherever that is. Is it D? There we go. Oh, now they work. Odd. And it's what's it? PCI? No. PCI support. Is it PCI Express bus? PCI support. Message signal interrupts. MSI and MSI X. It won't hurt if you've got extra things in here. And IMMU, that's for, I think that's something for doing, dealing with. If you have IMMU, when people do the graphics card, when they basically use a graphics card for Windows VM for like games, that's where I think the IMMU stuff, but I'm not sure what it means. I won't pretend to know. I won't bullshit you like other YouTubers. So, oh, it's already ticked by the looks of it. And IMMU. So, so let's just do a search. IOMMU. Drivers, IMMU. Hardware support. That's AMD. Surely it's like generic. So XNOS IMU debug, these are all different processors, like however you're supposed to pronounce that stupid name. Exynos. It's some Greek nonsense. Right, it seems to be lots of different IMMUs. I'm not going to use it because I don't need it. Because I'm not going to. It's a VM. It doesn't have IMMU, so I'm gonna leave that. Processor and features, high memory support. So let's go back. It'd be nice to have that, I suppose. We don't really need it. Oh, what was it? Let's see if we could find it in here. Let's do what is it called? Oh, so this is not the same as the interface I've got. So processor type. Yeah, I'm in the right place. Let's just go through this one more time. I don't really need this. So I can't find it in the next few minutes. Because it's got 4 gigabytes of RAM on here. My whole just now. Ultimately, if we ever compile it again, we probably do want to have this, but maybe this is like something that's standard now. And the book's wrong. You know, you might just not have updated this. And I know that's for fact because that was not quite in where it was. Oh, it was actually. Maybe I'm just an idiot. Processor type of feature. Yeah, I'm in the right bit. Oh, this is why most people don't want to do this. And everybody runs Ubuntu. Right, I can't see that. So we're just going to, and device drivers, NVMe support. Okay. We go device drivers gain. We do NVMe. Oh, that one's nice and easy. Oh. All right. So. Yeah, I don't care about bit. I can always recompile the kernel. It's not like, if we get it a bit wrong, it's fine. So now, and he has like a list of why he's chosen all of these things. Now, I'm just gonna let's just exit out of here. Yes. Now, I'm not gonna read all of these. Well, do we want to read all of these? Because I kind of know what they are. Anyway, so we'll just read the next bit of the book. There are several other options that may be desired depending on the requirements of the system. For a list of options needed for the BLFS packages, see the BLF index of kernel settings. Okay, so I suspect because this is more orientated to get like a desktop or server system set up. So basically a workstation or server. You'll have like a lot of other bits and pieces in here. What we're trying to do is just get something to boot. So I think you can read this all yourselves. For those, this one is interesting though. Most of these are like panic screen fault. Yeah, you probably want it package. Yeah, there's some security features. I'm going to read out two that are useful. So one of these was maintain a dev temp fs. So that is, we have udev. That's why he's had it on there. We compiled udev in a previous chapter, previous video. Fine. Panic screen formatter. User friendly. Yeah, so we'll get some output format so we can actually read it. Okay. All right, so basically enable legacy FB dev support for MoTent driver and frame buffer console support. These are needed to display a Linux console and GPU driven by DRI, direct rendering infrastructure driver. As config DRM, direct rendering manager is enabled. We should enable these two options as well, or we'll see a black screen once DRI driver is loaded. Amazing. Support X2 APIC. Supports running the interrupt controller 64-bit X6 processor in X2 APIC mode. The X2 APIC may be... The thing is there's so many acronyms and there's no way anybody could fit all of this stuff in their head. X2 APIC may be enabled by firmware on 64-bit x86 systems, and the kernel without this option enabled will panic on boot if X2 APIC is enabled by firmware. Option has no effect, but also does not harm if the X2 APIC is disabled by the firmware. Okay. Alternatively, make old config may be appropriate for in some situations. Nope, we're not doing that. Desired, skip kernel configuration by copying the config file config from the host system, assuming it's available, to the unpacked Linux 6.13.4 directory. However, we do not recommend this option. It's often better to explore all the configuration menus, create kernel configuration from scratch. No. I kind of disagree with that. I'd rather just take something that, hey, this is like a desktop configuration that most of the distros use. And then if you want to drill into it, that's better. Compile the kernel image and modules. Okay, let's go. Let's do make. See what happens. And now this usually takes a while. So I'm going to mute and just record the kernel messages going by. Right, so that actually didn't take too long, which is good. And the next thing we need to do is in building kernel modules. So it says here, if we're using kernel modules, module configurations in etc modprobe.d may be required. Information pertaining to modules and Linux configuration is located in a view of device and module handling. And in the kernel documentation, Linux 6.1.3.4 documentation directory, also modprobe d.5. That's man 5 modprobe d. So if you're not familiar, Oh, I'm still in here. No, quit. We do man man 5 mod pro. That is the man page. So whenever they say that, that's I might not mention it. That's what they mean. Is the man 5. Unless module support has been disabled in the kernel configuration, install modules with make modules install. Right. I don't know if I enabled any modules, but let's just go for it. Install. Okay. So some EFI for files. There wasn't very many. Cool. Right, so what we need to do now is we need to copy the kernel over into the right place so it knows how to boot. So it says here, after kernel compilation is complete, the initial steps are required to complete the installation. Some files need to be copied to the boot directory. Now, I didn't have a separate boot because maybe you want to use this, but I don't. Yeah, so I don't have a separate boot, so that's not relevant. The path of the kernel image may vary depending on the platform being used. The file name below can be changed to suit your taste. So we use an x86-64. So file name below can be changed to suit your taste, but the stem of the file name should be VM Linux to be compatible with the automatic setup of boot process described in the next section. I'm sure there's like a way everybody says that, by the way, but I say VM Linux. That's how I say it. The following command assumes to be the x86 architecture. Well, we're using the x86-64. So let's just see if we can. What we're going to do is we're just going to do copy IB arch x86-64 underscore 64, and it says boot BZ image, and then we want to do that to actual boot, and we want to do that. So that's the kernel version we built. Now, if you let's just go to Debian quickly, and basically, if you go to CD boot in Debian, and there is your VM blah blah blah, and it has the AMD 64 in the end. He says you can name it wherever you want, but you do need this bit on there. What he's saying there. We'll come back to 50% ish. Let's just do. There we go. And the system map is a simple file for the kernel. It maps the function entry points of every function in the kernel API, as well as the addresses of the kernel data structures for the running kernel. It's used as a resource when investigating kernel problems. So most compiled languages, because they compile it to either native code or onto essentially like a JVM, like a virtual machine of some sort, or like some sort of runtime. C#, it's called the Common Language Runtime. I don't know if it's the same as a JVM, but it's not important. It's usually low level what I'm doing. So what happens is it compiles and you lose a load of information. What this system map does is it goes and says, hey, this is where this is. And you actually get this in JavaScript as well. You get a map file. And the map file helps you debug compile source. So what you can do, if you include a map file as part of your build, usually as a local, when you're developing on local host, there's a map file. The map file goes to tells Chrome where the real functions are. So if you're a TypeScript dev like me, TypeScript doesn't actually run in the browser. It gets compiled to JavaScript. And then JavaScript runs in the browser. However, to map it back to TypeScript, there's a map file. and that's what the mat file does. And this is the same thing. So we're just going to do. Boop. That's the system mat. Done. Kernel configuration file config produced by the make menu config step above contains all the configuration selections for the kernel that was just compiled. It is a good idea to keep this file for future reference. Okay. We will do that. Install the documentation for the Linux kernel. There we go. Right, so let's just read this bit. It is important to note that the files in the kernel source directory are not owned by root. Whenever a package is unpacked as user root, like we did inside chroot, files have the user and group IDs of whatever they were on the package's computer. This is usually not a problem for any other package to be installed because the source tree is removed after installation. However, the Linux source tree is often retained for a long time. Yeah, if you're building it, I suppose. Because of this, there's a chance that whatever user ID the packager used will be assigned to somebody on the machine. That person would then have write access to the kernel source. Okay. In many cases, the kernel configuration, the configuration kernel will need to be updated for packages that will be installed later in BLFS. Okay, but we're not doing that. Unlike other packages, it is not necessary to remove kernel source tree after the newly built kernel is installed. If the kernel source tree is going to be retained, right, so what we're going to do, we're going to run that on this tree. Linux. Right, so if the kernel source tree is going to be retained, yeah, I just did that. If you are updating the configuration and building the kernel from a retained kernel source tree, normally you should not run the make Mr. Proper command. I always read that as Mr. Proper. This man called Mr. Proper coming in. The command would purge the config files and the O files from the previous build, despite it's easy to restore the .config from the copy in boot. Purging all the O files is still a waste for a simple configuration change. So I think the O files are the object file, so it's an intermediary step. I think it's the object files. I'm not. There's .o files, so need to be rebuilt, and the kernel built-in will correctly skip other .o files if they are not purged. On the other hand, if you upgraded GCC, you should run make clean to purge all the O files from the previous build, or the new build may fail. But yeah, because those O files are not on the right version of GCC. Makes sense. Some kernel documentation recommends creating a symlink from the USR source of Linux pointing to the kernel source directory. This is specific to kernel prior to 2.6 series. Yep, I remember that. It must not be created on an LFS system, as it can cause problems for packages you may wish to build once your base LFS system is complete. Right, so we're ending. I'm not going to do Grub today. This is already over an hour, and Grub scares me, so I'm gonna have to I'm gonna read this several times and have a plan in place before I do it on here, because I don't want to end up with an unbootable VM or overwriting something, because Grub always scares me doing anything with Grub. Most of the time, so it says configuring Linux module load order. So sometimes you have to change like when stuff loads, otherwise it just won't work properly, basically. I think like if you want to frame buffer support for like proprietary in the video, you have to blacklist certain modules and make sure they load up at the right time. This is all in the Arts wiki somewhere. And so this is probably a bit of what we're going on in here. So anyway, we'll read, because I'm probably wrong. Most of the time, Linux modules are loaded automatically, but sometimes it needs some direction. The program that loads modules, modprod or insmod, uses etc modpro.d usb.conf for this purpose. The file needs to be created so that if the USB driver is ehci underscore hcd or ohc ohci underscore hcd and UHCI underscore HCD have been built as modules, they will be loaded in the correct order. So EHCI underscore HCD needs to be loaded prior to OHCI underscore HCD and UHCI HCD in order to avoid a warning being output at boot times to be outputted, surely. Create a new file in etc modprod.usb.conf by running the following. Okay. Done. And we're going to leave it there today, as I said. I will do another video just about doing Grub. I need to look into my strategy, how I'm going to do this. I might have Debian boot, because I've already got Grub in the VM, because that's what is usually boot Debian. So I might be able to just update the Debian to boot my kernel. However, Debian has got like some etc defaults Grub, and it's got a load of it's done through some bash config, whereas in here they have, it's like a straight up it's a straight up sort of, you write these bits in the Grub process. In fact, let's just have a quick look at it. So I'm not gonna just in here this. So let's just have a look at the Debian one first. But I'm not gonna do this today. This is like a preview for the next video. Oh, seriously. So this is what gets outputted. So this is the Debian one, and this is generated by what is in defaults. And then there's the way that Debian does it, and I think this is how most Linux distros do it. They have a script that generates your Grub config. So there'll be like something like update Grub. So if I quit out of this, be update. If I do sudo su, if I do update, won't actually do it though. It's update Grub. There's that script. So if I do that, okay. It's update. Okay, is it function then? Got Ruby gems on this computer. What the hell have I got? So I actually did run it, but it's harmless. So what that will do is it'll go and it'll basically go and find all your. So if you install like a third-party kernel, like Xanomod or whatever for gaming, what this will do, it'll go and find your Linux images that are in the boot bits and pieces, and it'll write the Grub config. But there's also, if we just exit out here, because it's a bit scary doing stuff in here. So if you go into cd etc grub, and you see there's grub.d, we go in here. There is all of these things. So there's OS Prober. So if we cat 30 OS Prober. So what OS Prober does is this will look for different operating systems, i.e. Windows, and some other bits and pieces. I'm not sure exactly what this does. There's probably some do OS Prober. This package detects other OSs available at the system and outputs results into a generic machine readable format. So what this does is it runs OS Prober and then goes and works out what else is on your system. So what it does, I guess it will scan the other drives, work out this stuff there, and it will go and add that to it. So I might be able to use this just to go, hey, I've got a Linux kernel here. There's some like herd, just in case you've got like a GNU herd. If you're not heard of herd. Anyway, I'm not going to get into all of that nonsense. So there's a load of bits and pieces you can do in there. I have messed about with Grub so much, but Grub still scares me, especially writing a config from scratch, even if it's like, you know, directed through this book. So what we probably need to do is add this. So what I'm likely to do is add this menu entry in there for LFS into Debian, update the Debian config, and then see if it boots. That's my plan. And I'm going to see if that's like a good idea or not. So we'll see. We'll see. Why is it set root? I'll have to look at all of this again because I haven't done this properly in years. It's talking about like all this stuff. What I'll probably do is I'll probably just clone the whole VM. Hopefully I'll have enough disk space on my computer because I'm running out of disk space with all the VMs and stuff I've got on here. So anyway, that is a discussion for another day. It won't be happening today. So hopefully people found that useful, and hopefully I'll see you in the next video. So bye-bye.